we just shared an example with you regarding the assignment, addition assignment operator with the values of a as 10 and then we added 5 to it. The similar can be performed with subtraction also. So if we replace the plus sign with the subtraction sign, what will happen? If the previous value, that is the value of a is 10, when printed it gives 10. Now if I perform this operation as a minus equal to 5, what will happen? This statement a minus equal to 5 will be replaced by a is equal to a minus 5. The present value of a is 10 minus 5. 10 minus 5. The operation will be performed. The result is 5 and that will be stored in a. So if we print this, the result will be 5. So 10 is the previous value of a. When this operation is being performed, it replaces the operation by a is equal to a minus 5, which is actually a is equal to 10 minus 5, and the result of 10 minus 5 is stored in a, and when we print a we get the result as 5. The similar can be performed for multiplication, for division, for modulus, that is the remainder assignment, and for the powers also. So let us try this with the powers. So if we have a exponent assignment equal to 5, instead of 5 let us put 2. So the operation is quite simple. If we are writing like this, the operation will be like similar. The operation will replace a by 10 and the operation will be performed something like this. So the new value will be 10 raised to the power 2. The new value of a will be 10 raised to the power 2. The value of a will be replaced by 10 and 2 as the power. So it will give you result as 100. Right? So you can practice all the operators one by one like this, like a double slash 3. That means the value of a will be divided. It will perform the floor division on it and will give you whole number, right? Whole number as the quotient. If a, the value of a is a floating point number, then you will have the uh, whole number before the decimal, but after the decimal, the value will be 0 only. There will be no precision value other than 0 in case of float number. In case of integer, the float division always returns quotient as integer number only. Let's be a little logical now. Logical operators are composed of Boolean expressions, which are either true or false. They are required for the creation of conditional statement as well as for the managing the flow of execution in programs. So Python has basically three basic logical operators, that is and, or, not. And can be written in small or it can be written in caps. It will not make any difference. It holds the same meaning. And in small and in capital holds the same meaning. Similarly, or in small or in capital holds the same meaning. Not in small and not in caps hold the same meaning when used with the values. Now, when we are performing a logical operator, when we are doing some operations like this with and or not, so basically we are connecting the comparison operations together in under one roof, like two comparison operators. We just started the comparison operators here. We are performing the two comparison operations on either side of the operator. For example, the first operation here you can see is 5 double equal to 5. So this is one equality comparison we are performing. And on the right hand side of the operator, we are not holding any one single value. That is one complete operation we are performing with and or not. Especially we are using this operator to connect multiple comparison in a single set of statement. When we have multiple conditions, if you think of any triangle, like if you have to prove something like this given triangle is an isosceles triangle or not. So what are the properties which comes to your mind that two sides of the triangle needs to be equal? If you wish to prove any equilateral triangle, that the given triangle with the angles are is an equilateral triangle, then the mandatory thing is that the sum this measurement of angles of all the three angles of the triangle need to be same. So we have three comparison to be made. Angle 1 will be compared with angle 2, and angle 2 will be compared with angle 3, and so on. So you have multiple comparison. When you have such kind of situation, then the logical operators are used. So in the case of and, when two comparisons are being made on either sides of the operator, it means both the conditions need to be true. Only then the result will be true. Like in this case, 5 double equal to 5. It is true. Yes, 5 is equal to 5. And 6 is less than 5. Now this is not true. This is false. So the result will be false. If either of the one is not correct, is not generating the result as true, then the complete result will change into false in case of and. I have also mentioned one more example here where I'm taking the value of x as 10, y as 15. Now, instead of values, I'm performing the operation on variables. X less than y. When we are writing x less than y, then we are replacing the value of x by 10 and y by 15. So what we are doing is 10 less than 15. The answer is true. And y greater than x means 15 is greater than x. It is also true. So both the condition are true, then the result is true. If either one is not true or both are not true, then the result is false. Or says that in the comparison, if any of the value, any of the comparison result is positive, that is true, any one, like 5 is equal to 5, yes it is, or 6 is less than 5, if it is true, either one is true, then the result is true. So if both the condition are true or either one is true, then or says the result is true. But if both the condition are opposite, that is, they are not giving some positive impression, they are not true, they are false, both the conditions, then the result is false. Let's see this example. Again, 10 is x, the value of x is 10, value of y is 15. X is greater than 10. Is 10 greater than 15? No. Is 15 less than x? No. So both the values are false. That is why the result is false. Let's perform an action. I say the value of x as 25, the value of y as 20. Let's revise some comparison operator first. Let's print the result of x, comparison of x and y. So I want to perform one basic comparison, that I want to print the result of x greater than y. So value of x, what will happen? 25 will be compared with 20. What do you say the result will be? The result will be true or false? It will be true. It will be true. Because yes, 25 is greater than 20. But what if I replace this with less than sign? What will happen? It will say false. Now, in the given scenario, if I add the logical operator and I say if x is less than y and y is less than 10, then please tell me it is true or false. Now in this case, what is happening? X is being tested with y, that is 25 is less than 20. What do you say? It is true or false? It is false. 25 is not less than 20. And then we added and we are saying is 20 less than 10? True or false? So this statement also give me false and this is also false. So both the false give me false. Now I will just change the operator from less than sign to greater than sign. Now this is true. 25 is greater than 20. still the result will be false, because and says both the condition needs to be true, then only the result will be true. Otherwise, in all the cases, the result will be false. So there are four possible conditions where left side value is true and right side value is true. Then the result is true. If left side is true but right side is false, result is false. If left side is false and right side is true, result is false. And if both the sides are false, the result is false. One simple change I will do the program. I will replace this and to or. Now consider this situation wherein one condition says that 25 is greater than 20. It is true. Now, in the second case, I'm saying 20 is less than 10. It is false. 20 is not less than 10. But I have replaced and with or. What does it mean? That either of the condition, if it is true, the result will be true. The result will be true. Either of the condition. If both the condition is true or either of the condition is true, then it gives me result as true. Now I have made the change. What I have done, I have given both the positive conditions here, that 25 is greater than 10 and 20 is also greater than 10, the result is true. What happens when I change both the symbol here? 25 less than 10, 25 less than 20 and 20 less than 10. What do you think we are doing? Is 25 less than 20? No. Is 20 less than 10? No. Both the condition are false. So let's see how OR will give you result. It gives false in this case. So either of the condition, if it is true, if it is satisfactory, then we are ready to get the true as the value. But if both the condition are false, then OR will also not give us true as the result. It will give false as the result. Then what is the purpose of not? Not is reversing the result we are getting. So if it is true result we are getting, it will make it false. Like if I say, a simple statement like print x greater than y, again, what will be the result? The result is true, right? Now, if I simple write not, I can write this in print statement, and because this is single statement, I can write simply like this also. In the print function, I'm writing not x greater than y. Now we just tested that x greater than y gives us true. But I have now put this expression, that is x greater than, this comparison inside the not function. Let's see what will happen. It gives me false. So it gives me the reverse result. Means if it is true, it will give me false. And if it is false, it will give me true. So you will come to know about the use of this operator in your programs further. So it is just for your knowledge purpose. An amazing operator, membership operator, very useful, very nice to use, and it has a good meaning. It is widely used in the program, especially in the case of sequence variables. It is used um, very frequently. So we have two operators, in and not in. In means we are checking the existence of the value in a sequence, existence of a value. If I am one of the teacher of a school, then my name should exist in the teachers list. If my name is existing in the teachers list, then yes, the result is true. Again, the Boolean result. The result is true if my name exists in the school teachers list. But if my name is not in, then I can do something. I can ask them, okay, if my name is not in the teachers list, please do me a favor, add my name in the list. If I'm a new admission in a school and my name is not in the record register or attendance register, I can ask my teacher, please add my name. But if my name is there in the register, then I'm happy. So the condition varies. So in this case, example, if you see, it says X and Y. So Y is what? It can be any sequence. Any sequence. It can be dictionary, it can be set, it can be tuple, it can be a list. We are checking the existence of X value, the value in X variable in Y sequence. So if it exists, it gives us true as the result, otherwise false. And not in gives me true if it is not available. If X is not a member of Y sequence, if it gives the result as true. If it is a member, it gives us false. So you can see example here, list 1 has value as 10, 12, 14, 16 and 11. I have taken one variable as X as 14. Now I'm writing X in list 1. What do you think it should give me? True or false? It should give me true. For your satisfaction, I'm just designing the same for you. 10, 12, 14, 16 and 11. So what we have done is X is equal to 14 and we are checking X in list 1. Membership. We are checking the membership of X in list 1. So let us change this value to now 17 and X in list 1. It is false. X is not in list 1. So we are not basically checking X. We are checking 17 in list 1. When we are writing X in list 1, the 17 will be replaced in the given expression and it will be checked in the list that is 17 member of list 1 or not. If it is member, it gives me true. If it is not member, it gives me false. Then what will not in do in this case? Not in. It will give true as the result because yes, 17 is not in list 1. It is not present. List 1 has 10, 12, 14, 16 and 11, but 17 is not in list 1. Change the value 11. Is 11 in list 1? Yes. So what will be the possible result? False, because 11 is in list 1. So it is giving me false. Not in gives you a positive result when the value is not present, not a member in the sequence. But if it is member, the result will be false. Let's look up for the identity operators. Is not. Very interesting to use. Is or is not. Different from what we studied in, a little similar. Is gives me true when a particular value is being referencing to the same memory address from where the other value, other variable has been created. So if they are pointing, like if me and my friend are sitting on the same bench, then we share the identity there that this desk belongs to us. But if we are sitting at different places, how can we have share the same identity? We cannot share the same identity of the disk because we are sitting at different place. So memory is a kind of block where each value gets a location to be saved. And if we have two reference to the same memory place, then we say they are identical to each other. They hold the same identity. So in this case, like list 1 holds two values, right? And then we have X is equal to 13. Now list 1 is a list and X is an integer type variable which is holding value 13. Obviously they are not.
This meeting is being recorded.
Now in this case, in this example, I have created one of the list which is holding two values 10 and 12. And then I have one X as the variable which is holding value 13 and it is of integer type. When we are creating variables, each variable on execution gets a memory location for them. If we think logically, the list has been created first, it should be allocated memory first. Then X is created. So X is being created independently. It has no relation with list 1. Then if I make a check that X is list 1, it should give me result as false, because they are not holding the same memory location. They are completely different from each other. They are not member. They are not relation. They are not related. They have no same pointer, same object location. They are different in identity as well. One is list, one is integer. They are not same. But now I'll make a little change to this. I'm saying X is equal to list 1. What do you think I have done? I have created a list 1 with two values, and I'm saying X is equal to list 1. So a memory block was assigned to list 1, the two values. And now I have created one separate variable X, which is pointing to the same location where the values of list 1 are stored. So are these both the list 1 and X holding the same identity? Let's check. Is X list 1? The result is true, because now they are holding the same type. What if I just roll back my program here and make it 13? Again, the result will be false, because now they are separate memory location. Let's change the is to is not. What do you think will happen? Is X list 1? The result is false. Now, is X not list 1? The result should be true, because X is now not holding the same identity as list 1, that is not, gives me result as true. They are not holding the same identity. They are referring to different memory locations. So all these operations are performed according to the need, and many times they are used with sequence object, or when we are checking the place of location, so that we are modifying value of one variable, will it reflect to the other as well or not? So there are many cases you will come to know or practice with the time, with the programs. But presently, to understand the meaning, is gives you true result when both the objects are pointing to the same memory location. Otherwise, it is false.
This meeting is being recorded.
Last but not the least, we have bitwise operator. Now, this is very interesting to study. Bitwise. Bitwise operator executes operation on individual bits of binary integers. They work with integer binary representation and performs logical operation on each bit location. So here when you see and is represented by ampersand, or is represented by the pipe sign, um, XOR is represented by the other sign, and then complement and left shift, right shift, and AND. But before we start understanding the binary, it is very important to see what do you mean by binary. Now, each number is represented in the form of some ones and zero, because that is the language of computer, ones and zero. Every bit of information, if I say 1 byte is equal to 8 bits, then each 8 bits is a combination of ones and zeros. Let's say if I have X as the number 10, then how can I know what is the binary value of X? Because X is a decimal number. X is decimal means the computer, you have number representation as binary, you have decimal, octal, hexadecimal. So when I'm writing X is equal to 10, it's a decimal type number. If I want to see the binary value of this number, I have to use one of the function called bin and write X in this. So on playing of this code, you will see something like this. So this is how computer understands 10 as a number. We can change the number to 1 also, and you can see the binary representation of the number. You can make it more big. If you want to make it 100, you can make it 100 also, and then you can see. So it is giving you the number as 10. Just please see the number. This 1100100. It is giving you the number as binary number. This is how 100 is represented as binary number. So now it seems little logical if you say, and we have used, it checks the logical condition, but it is not the case of bitwise operator. It is different in bitwise operator. So if you have x as 1 and y as 2, what will happen if we perform the AND operation to it? What will happen if we perform the OR operation to it? Each digit of 1, each digit of 1 will be added. The binary digit of 1 will be added to binary digit of 2. And then if both the bits are 1, then the result of the operation is also 1. Let us understand this first. See the bin of x and bin of y, so that you can perform this calculation yourself also. Bin of x and bin of y. See the value. Bin of x is 1 and bin of y is 10. What happens when we perform the AND on it? Let's print the result directly, or I can store the result in C also, but let us have this. Now, let us write simple operation. As I told you before also, all the operator has two operands and the operator are provided on the left and right hand side. So we are writing x ampersand y. What is happening? Let us see the bin value of it. Bin x and y. So it is 0. It has performed the addition to both the numbers here. Now, when it is performing the addition, in the first case, it is adding 1 to 0. In the case of AND, if both the digit at one's place, that is the 0th place, for 1 it is 1 and for 2 it is 10. So 1 will be added to 0. Ampersand says if both the digit are 1, then the result is 1. Otherwise it is 0. So in this case, when 1 is added to 0 here, it becomes 0. Similarly, this one is added to 0 because 1, if it is independent, 0 is assumed to be before it, and if it is added, it gives again 0. So bitwise operator says the result is 0 in this case. Let us change this ampersand with the OR operator, that is pipe sign. What will happen? The result is 1 1. In the case of OR, it says if it is 1 and 0, the result is 1. If it is 1 1, the result is 1. Only 0 if both the bits are 0. So this operation, what it is doing it is adding 1 with 0, which is giving result as 1, and then again 1 is being added to 0, it is giving result as 1. Because either of the bit is 1, so the result is 1. But in the case of ampersand, if either of the bit is 0, the result becomes 0, and similar is the case here. When it is 1, when it is 1 plus 1, only then the result is 1. Otherwise, it is 0. So this is the bitwise operator, how it is performing. So a lot of operations has to be practiced from your side as well. I wish you good luck for your practice, and soon I'll be posting new video on conditional statement. Thank you.